itself, no? So non-uniform, there will be net force.
Force must be non-zero. Both may be non-zero.
So non-uniform this thing, so force will be there. Torque will always be there, even if it's uniform. So both may be non-zero. So this is the correct one.
Yes, sir.
3, 4. Okay. Electric dipole has magnitude. Dipole moment P displaced in uniform electric field, which dipole around the axis of the dipole is around the direction of the field. The force on it is proportional respectively. Okay, this is an external field. No, okay. Okay, this is an external electric field. This also you know, because potential energy is, what is the formula for potential energy?
Minus P dot.
Yeah, so using that you will get this answer.
Minimum.
Okay, so what is the answer? So what is the angle between P and E?
0 degree.
So then the potential energy will be maximum, right? Minimum.
Minimum.
And then what about the force? Force should be 0, right?
Okay, uniform matrix. Yes, sir.
Yeah. Okay, this one. So work done is that correct?
Yes, sir.
Work done will be the increase in potential energy, right? So potential energy is P dot E.
Minus P dot.
Yeah. So change of this one. So by 90 degrees he's saying, but he's not saying from which angle to which angle. So let me assume one of them is 0 degrees, the other one is 90 degrees. So the change will be P into E.
Plus P.
Yeah. Not necessary, because if your initial point is 90 degrees and the final point is 180 degrees, then it will be minus P. But since there is only one option whose magnitude is P, then there is no confusion. Is it clear?
Yes, sir.
Okay, dipole moment P is placed in uniform electric field intensity. The dipole acquires a position such that the axis of the dipole makes an angle theta. Okay, with the direction of the field. Assuming the potential energy of the dipole is 0. Okay, potential energy is 0. This is consistent with the formula, right? Because P dot E minus P dot E, it's minus P cos theta. So for theta equal to 90, it's 0. It is consistent with that assumption. Okay, that formula is valid. Some background noise is there.
Third option.
Torque and potential energy dipole will be.
Option 3.
Torque is P cross E, so it's P sin theta, and potential energy is minus P cos theta, minus P dot E. So why has he given this condition? That is to that formula, potential energy is P dot E minus P dot E. It's under the assumption that at theta equal to 90, the potential energy is 0. Okay, so this is consistent with their assumption. So this way, this information is given. Okay.
Yes, sir.
The dipole moment P is placed in non-uniform electric field, and along the x-axis, electric field is along the x-axis. Electric field is at increase. This also I have solved earlier. At a rate of, so in the force in the dipole is. So what is the answer? Do it quickly. Non-uniform. So let the electric field be E1 and E2. Along the x-axis. Got the answer?
No, sir.
See, the electric field will be different, right? For minus Q and plus Q. So this is minus Q. This is plus Q. Okay, so let the electric field here be E1 and E2. Okay, so the force on this will be QE1, right?
Yes, sir.
And the force on this one will be in this direction. Plus QE2. So he has said the placed. So what is the direction of P from minus this thing to this thing, right? So this is the direction of P vector.
So QE2 direction will be towards right side.
Oh, see, the electric field direction is this way, right? External electric field.
Okay, then force is opposite. Fine.
So don't go too much into mathematics. Don't think physically. Otherwise you'll make mistakes. Okay, force on the positive charge will be along the electric field. Force on the negative charge will be in the direction opposite the electric field. E1 is the magnitude at this location. E2 is the magnitude at this location. And field is increasing at the rate of, so how much is E1 in terms of E2? So E1 will be E2 plus something, right?
Yes, sir.
So how much is that plus something? E2 plus delta E, and this 1 volt per meter, this is 1 volt per meter. Okay, so it's 1 into 2E is delta E.
Yes, sir.
Net force Q into E1 minus E2, that is delta E 2A. So this is equal to P. Is it clear? Okay, you want to find how E1 and E2 are related. So E1 is this is the positive x-axis, and along the positive X is increasing, electric field is increasing at the rate of this one. Okay. And so E1 is greater than E2 by delta E, and the delta is the gradient of the electric field, that is 1 into the distance between these two. The distance between -10 plus Q is 2E. It's Q into E. So the delta electric field is increasing by an amount P. Net force is Q into E1 minus E2. So Q into delta E. That is P. Is it clear?
Yes, sir.
What is the background noise?
Fan, sir.
Fan.
Yes.
Okay.
Sir,
Yeah. Is it okay?
no, sir.
No. See, the dipole is placed on the x-axis, no?
Yes, sir.
Okay. And he's saying the direction of the dipole moment P is along the positive axis. So my P is from minus P to plus Q. Right?
Yes, sir.
So it's along the positive. So this orientation is clear, no? Okay.
Yes, sir.
And
Up to that E1 equal to E2 plus del E. I
Ah.
understood.
so delta E is what? The gradient of E. So it's dE by dx into delta x, no?
Yes, sir.
dE by dx is this quantity
Okay.
because electric field is increasing at a rate. So this dE by dx
Yes.
from the unit is volt per meter per meter. So this is electric field divided by the distance. So the dE by dx is this one. So delta is dE by dx into delta x. And delta x is this separation. That is 2e.
Yes, sir.
So,
Yes, sir.
is it clear now? Okay.
Okay, then they asked just force on the dipole moment, sir.
Yeah, force on the dipole is Q into E1 minus E2, right?
E1 minus E2.
This is the force. Delta E is just 2A. This is delta E.
Then E2 and all. Okay, E2 minus E1. Okay, yes, sir. Got it.
So delta E is 1 into 2A, so it's 2A. Force is Q into E1 minus E2, that is Q into delta E. So Q into delta E is Q into 2E.
Okay.
Done?
Yes, sir.
Okay. So you have to try problems from your PYQs. So I already have I will send the link also, no, and you also have questions. So you have to try problems, otherwise it's not you will forget everything. Okay, right. So should I move on to current electricity?
Okay, sir.
Because I had solved problems from dipole and electrostatic problems also we have solved something. So you just try problems from this PYQs. Okay.
Okay, sir.
And if you're not, your screen is shared, no? Okay, fine. So should I move to next chapter?
Yes, sir.
Okay. Okay, this is current electricity. So what is electric current? These are basic questions. Can you tell me what you understand by electric current? It's flow of what?
No charge.
Yeah. And what are the two requirements to produce current? So what are the two things to make the charge to flow?
Resistance and potential difference.
Basic than that is the charge has to be free. Okay. And then there has to be a force to push that charge, right?
Yes, sir.
So basically free electrons has to be there in the case of metal. And also the force to push is given by what? Charges are free. Okay. In addition to that, you have to push the charges, no, because charges have to move. So the pushing of the charges is done by what? Electric field, right? A charge in an electric field will experience a force. And the electric field is provided by the potential gradient. And the potential gradient is provided by whom? The cell.
Yes, sir.
Okay, so at the basic level, you can say the charge has to be free and there has to be an electric field. Okay.
Okay.
And Ohm's law is what?
Charge can either be it's not Ohm's law.
What? Ohm's law is relating voltage and current. It says voltage is directly proportional to the current. If you increase the voltage, the current will increase in a resistance.
It's B equal to I1.
Okay, so these are all very basic, so I'll go through fastly. Electric current across an area is the amount of charge crossing the area in unit time. Okay, this you know, right?
Yes, sir.
So this is a conductor. So if it is metal conductor, solid conductor, the things which are moving are the electrons. Okay, the ions are fixed to the metal. Okay, you do not move. Only the electrons will move. So what is the direction of electric field here? Towards right or towards left? These are electrons.
Left,
The
sir.
electric field direction will be like this.
Yes, sir.
Because negative charge will experience a force opposite to the electric field. When the current across this cross section area is Q by T. So right, Q is the amount of charge crossing the time. And if you take a small amount of time delta T, and whatever is the charge crossing in that time delta T is delta Q. So the current is delta T by delta T. And the unit of charge, you know, coulomb, time is second, and the current is charge divided by time, and the unit is ampere. So ampere is related to the units coulomb and second as 1 ampere equal to 1 coulomb by 1 second. E is C by S. Steady current means the thing is not changing with time. So with respect to time, it has to be constant. This is a steady current. And I is delta Q by delta, which is same as Q by T. And this is an example of time varying current. The current is increasing and then it remains steady and then it decreasing. And for a time varying current, they will take a small interval delta T, and whatever is the charge crossing the interval, that divided by the time gives the current in that time interval. If this time interval is very, very small, then it becomes instantaneous current. This is average current over a time interval. When the time interval is becoming very, very small, it becomes instantaneous current. Electric current in conductors. So first we have to recollect how the electric field is defined. Electric field is force on unit positive charge. So electric field due to a point charge Q is using Coulomb's law. We have to put Q to 1 because of force on unit positive charge divided by the distance square. So this is expression for electric field for point charge. This is by Coulomb's law, and using the definition of electric field, that's a force acting on a unit positive charge. So two requirements to produce a current. As I said earlier, it's free charge and the force to push it. Force to push it is going to the electric field. So this you already know. For metals, the positive ions are fixed, they will not move. So the free charges are the electrons. But in solutions like salt mixed with water, here both the positive ions will move and the electron will also move. And here the negative ion. So both positive and negative ions will move in electrolytic solutions. But in conductors, which you are considering in this chapter, only the electrons will move. This you know, right?
Yes, sir.
Okay, Ohm's law, as I said, is going to relate voltage and current. So if I plot voltage and current, it will be a straight line, and the straight line will pass through the origin. Why does it pass through the origin? It passes through the origin because when the applied voltage is 0, the current will be 0. Okay, and it is
Initial
straight line.
value.
What?
5.
And the slope is the resistance. Here is 1 by R because on the y-axis it's current. So why do you plot voltage on the x-axis? Any reason for that? Current is on the y-axis. Why not the other way around? Usually on the x-axis you plot what?
I don't know, sir.
Which one?
I don't know, sir.
Okay, usually on the x-axis, it's dependent variable. Sorry, independent variable. On the y-axis, it's dependent variable. Okay, what is independent variable? The thing which can be changed easily, or you can say input to the system. And dependent variable is the one which is depending on this input variable, or we can see the output of the system. So usually we have voltage sources. So voltage is the one which we can vary independently, like a variable voltage source. You don't. It's not easy to get a variable current source. Okay, so what is easily available is variable voltage source. So usually voltage is considered as independent variable, and the y-axis is dependent variable, depending on the independent variable. So what you can say, voltage is input and current is output. Output is dependent on the input. Input is more free to vary. Okay, so but they can plot it the other way also. In that case, the slope will be delta V by delta I, that will be resistance. And the resistance is a property which depends on the material of the conductor and also the dimensions. Okay, so if the length of the wire or conductor is increased, so the resistance will increase. This you know, right?
Yes, sir.
So the way to understand this is, this is the length. So the current has to cross this much distance to come out of this side. So if the length is increased means then it has to do more work to come on the other side, no?
Yes, sir.
So it has to come out, it has to overcome more resistance. So as the length increases, the resistance increases. What about the area? If I increase the area, the resistance, it will go down, right?
Yes, sir.
So how do you understand that? So this is the wire. So the current will go through this wire. So increasing the resistance is like having one more wire here. So now there are two paths. Okay. So the more amount of current will come here.
It's a more charge
So
less than.
it's as if the resistance of the resistance to the flow of charge is reduced. So it's inversely proportional area. So combining these two, we can say resistance is proportional to L by E. Okay. And the constant of proportionality is rho. It's called resistivity. And it depends on the material of the conductor and not the geometry. So copper will have one value. So just because the wire made of copper, the length has increased, the area has increased, or the area has changed, the resistivity will not change. It is depend on the material, not on the geometry. So rho depends only on the material. Okay. And this voltage and IR directly pushing this by Ohm's law. So and R is rho into L by A. That's what you have seen here.
Yes, sir.
So from this we get, and also we can define one more quantity. So the current we have defined as the amount of charge that's flowing through this cross-section area, right? So suppose I want to find this unit area here and find the current in this unit area, and assume that the current is uniform throughout this cross-section. Then the current in this unit area is the total current divided by the total area. Okay, so that quantity is called the current density, and we define that current density, denote that current density by a symbol J. J is I by E. This you know, right?
Yes, sir.
Okay, so here V equal to this one. So I divided by E, I can combine as J. So V equal to rho L by J. And assuming that the electric field is uniform, then V by L is written as E, electric field. Okay, so electric field is rho into J, and rho is resistivity. So reciprocal of resistivity is conductivity. Okay, so J equal to sigma E. So V equal to IR is one form of Ohm's law. Another form of Ohm's law is J equal to sigma E. Okay, I is current, J is current density, that's current per unit area, and V is the potential difference, and E is the electric field, which is gradient of potential difference. So it is V divided by the length of the conductor, if you assume that the electric field is uniform. So is this clear?
Yes, sir.
Okay. So inside the, see in this chapter we are considering only mainly solid conductors. Okay, so whatever is the thing which will move freely because of the electric field is the electrons. So the electrons inside a conductor, suppose there is no, these things you know, right? Suppose there is no, suppose you take a conductor like this, say made of copper. Okay, so what will be there inside? Electrons, no?
Yes, sir.
Free electrons, and there will be positive ions, but they are fixed. So I'm just considering the free electrons. So how will these electrons move if there is no, I'm not connecting to any battery or cell. Okay, so in that case there is no electric field, no? So in that case, how will the electrons move? Will it move or not?
Random.
Yeah.
We
So
move random
why does it move in random?
because there is no force pushing them towards a particular direction. Sir.
No, suppose I reduce the temperature of this copper wire, so will the random motions reduce?
Yes, sir.
So it's basically a thermal energy. So at T equal to what temperature this random motion will stop? It's moving at random, right?
Minus 273 K. Minus
Yeah.
273.
So at zero Kelvin it will stop.
0 degrees Celsius. Sir.
No, not Celsius, Kelvin. It's minus 273 Celsius. At 0 Kelvin,
Yes, sir.
it will completely stop. Okay, so
Yes,
if this thing keeps on this thing, then the temperature will be something. And if it is surrounded by atmosphere whose temperature is less than that, then the temperature of this wire will decrease. So this random motion will decrease. So in general, at room temperature, there will be some random motion. So this electron will move like this. After that, it will move like this. It will move like this. It will move like this. And finally, at some time, it will come to the same position. Okay, because there is nothing to push this electron in one particular direction. So on an average, it might come back to the same position. That is, so if we take a cross-section area, on an average, the number of charges crossing this side or the electrons crossing this side and the number of electrons crossing this side will be equal. So the current across this cross-section is 0. Okay, so once you apply the electric field, then the random motion will stop or not?
yes, sir. There is a direction. Particular direction.
No, the random motion will it be there or not?
There won't be random direction.
No, there will be random motion. In addition to that, there will be that drift. So it will move like this.
After applying electric field also.
Yeah, it will move, but in addition to the random motion, it will come here finally. The final position will be here, a little bit away from the initial position. Okay, suppose this is the initial position. Okay, after that, random motion will be there. In addition to that, there will be drift. So this amount is the drift because of the electric field. Got it?
Okay, sir.
Okay, actually, this random velocity is much higher than the drift velocity.
Yes, sir.
This is a random motion, V random. It's actually much greater than the V drift. But on average, the contribution of V random is due to the electric current is 0 because random is the direction is random, but drift is along only the direction of the electric field. So that this will give rise to current. So this is what is shown here. This blue line is the one which is okay in a given time. Finally, it might come here. So if this blue line is the random motion, because of the electric field, it will experience a additional force towards the right because electric field is towards left. Electron is negatively charged, so it will experience force towards right. And because of this force due to this electric field, it will be a little bit move towards right. This is because this is the drift. Okay, B is the position because of the thermal motion, and in addition to the thermal motion, there is a drift motion because of the electric field. So this is the amount of drift.
Yes, sir.
Okay, and velocity of drift is E by m into tau. What is tau?
Time interval.
Between what?
Time.
See this free electron, it will move right because of the electric field. Okay, as soon as it moves, see the direction of electric field is this way. So it will also move. So this electron here, in what direction it will move? Towards right. Electric field is towards left.
Yes, sir.
Can
Right
move
one.
can move in this direction? The electric field is towards left.
No, rightward only. No, sir. It will experience of both. Right.
Yeah. See, this is net motion because of random and this drift electric field. So because of this electric field will be towards right, because of random, it will be in any direction. Okay. So this is combination of random plus drift. Okay. So suppose this drift is not there, it will be like this. Sorry, not that much. See, a little bit away. Without the electric field, see, it is like this. Okay. So because the electric field, it has become this pink one. Got it now?
Yes, sir.
Okay. So yeah. So this electron, after it, so there will be positive ions, no? So this electron will go and collide with this positive ion. So once it collides with this positive ion, it will stop.
The part positive ion that will be in the nucleus only, no, sir.
Yeah. See, for example, copper.
These are free electrons only, no, sir. They are limited to that valence shell.
See, this is copper. Okay, outermost electrons are there. So these electrons are free to move. Okay, so this electron will go, and there is next copper atom, no, somewhere else. Okay, so it might, there is one more copper atom here also. So this electron will go and hit this copper atom. See, copper atom is that you can say copper ion. After once this electron is freely out, so it become copper plus. Actually, copper will give 2 electrons, 2 free electrons. So it will be Cu2. So copper you can think as copper Cu plus 2 electrons.
Yes, sir.
This is copper. So this electron will go and hit with this copper ion. And copper ions are fixed with the lattice. Only the electrons will move. So this thing will go and hit a copper atom and it will stop. So this distance or this time it takes to move from one atom to another atom is tau. And this tau is called relaxation time. That is the time it gets to relax between two successive collisions. Okay, and how do you get this formula? V equal to this one. How do you remember that formula?
Which one, sir?
The drift velocity is E by m into tau, right?
E tau by m. Yes, sir.
How do you remember this formula?
I know, sir.
Okay. See, you have to understand the formula. So, okay. So, you know V equal to U plus AT, right?
Yes, sir.
And U is 0 because this thing goes and collides with this one. Once it collides this one, the velocity is going to reduce to 0. For the next motion, the initial velocity is 0.
Okay.
Okay. So, similarly here also it will start with 0.
Okay.
So, initial velocity is 0. And what is acceleration?
Force by m.
And force is E into E, right?
Yes, sir.
And what is the time interval? Tau.
Relaxation time.
So the tau time interval is in between the two successive collisions. So that's how we can remember this formula. It's for acceleration in time. V equal to U plus AT, U is 0, so it's A into T, and A is force by mass. Okay, so now we can remember this, right?
Yes, sir.
Okay, and tau is the relaxation time. So the current that's crossing an area is the total charge which is crossing in a time delta T. So this formula also you know.
Yes, sir. N.
So how do you remember this formula?
I know that from
Okay,
practice.
see, one way to remember this is Veena. Veena is a name of a person, no?
Yes, sir.
Or the actual name is Veena. Okay, so V is the drift velocity, Vd, and E is the electron charge, N is the number density of electrons, and E is area of cross section. So this is one way of remembering the formula. Okay, and in fluid mechanics, suppose there is a pipe where the velocity of the water is say V, okay, and the density of the liquid is rho. What is the amount of liquid that's crossing this cross section area?
I don't know, sir.
Okay, this is cross section area in time in 1 second. Okay, so in 1 second, whatever is the volume of liquid in this region, that will cross, right? So the water element here will cross this one. The water element which is nearby will still definitely cross this one. And the farthest water element that will cross this area is at a distance V, because this element will travel a distance of V into 1, right? In 1 second, the water element will travel a distance of V into 1, right? Distance traveled is V into T. It's a uniform velocity, there is no acceleration. Yes, no, it's equal to ut plus half at square. Okay, so acceleration is 0, so the distance traveled is velocity into time, right?
Oh, yes, sir. Yes,
Okay,
sir.
so the farthermost of this one will travel a distance of V into T. So whatever is the distance of V, that element will touch this surface or cross this surface. So all the elements which are within this cylinder of length V and cross section area A will cross this area. Okay, so the mass that is crossing this area is the volume, that is V into 1. That is the volume, and the density. This is the mass that is crossing this area. You can say mass flux. Okay.
Yes, sir.
I missed something. It's A into V, right? This volume is A into V. Here is the cross section area E. The volume of this region is A into V. There is no 1 here.
Yes, sir.
That is the
Okay, mass
volume.
by 1.
This is the volume that's crossing this area, and the density will give me the mass that is crossing this area. That is the mass flux. Similarly, here in the case of current, it will be the charge which is crossing this area. So that will be the amount of charge in this volume into the volume, that is volume is V into 1. So this is the total charge that is crossing this area, and rho is the uh, charge density, that is number density of electrons in the cross section area. So this is the thing that's crossing in unit time. Since it is 1 second, this is the current time. So here you got V now. VE and A. That's the same thing that's here. And this V is the drift velocity. Okay.
Okay.
So either you can remember this formula as V now, or the amount of charges crossing this, which is same as mass that is crossing this in fluid dynamics. So there it's rho is the mass density. Here in the case of current, rho is the charge density, and charge density is number density of electrons into charge of one electron, which is E. So N into E is the charge density into the volume of the charge which will cross this area, that is V into E. So this is the amount of charge crossing in 1 second, which is same as a current. Okay, and current density is I by A. So it's E into N into Vd. Okay, and the drift velocity we got as acceleration into time. So this one. So we get this one. So current density J is proportional to electric field, and whatever is remaining, that is the conductivity sigma. So from this we get the sigma as this one. This one also you remember.
This one I don't remember, sir. From there I will derive.
Okay, so if you remember this one, I equal to this one. From this you can write I as J by A. So or you
Yes,
can say I by A is J, right? Bring A on this side. Okay, so J will become E into N into Vd, right?
Yes.
That's what I written here. And Vd, this formula you remember. Vd is this one.
Yes.
So from this you can get this one, and you know J equal to sigma into E. This formula you remember, right?
Yes, sir.
Second formula also. So from this, if you compare this one, you get this thing. Okay. So from that you can derive quickly this one, and resistivity is 1 by sigma. And mobility is how fast the electrons are moving. So so the drift velocity will be more if the electric field is more, right? If
Yes, sir.
I plot the drift velocity Vd versus the electric field. So the electric field is moving, the drift velocity of the free electron will be more. So the plot will be a straight line, and the slope of the straight line is mobility. This way I can remember what is mobility. First thing you have to remember is the drift velocity increases, the electric field is increasing, and it's increasing linearly. So it's a straight line relation. This also you have to remember. So once you remember this relation, then we can remember mobility as Vd by electric field. Or another way to remember the mobility is the velocity gained by the drift velocity gained by the electron for unit electric field. When E is 1, the mobility is same as drift velocity. So mobility is the drift velocity per unit electric field.
Okay.
Okay, so let's solve some problems so that you will remember things better and also understand will be better. So try this one. So you know what is mean free path, right?
No, sir.
You know relaxation time tau.
Yes, sir.
So the electron is here, and then it will move like this, and then it will collide with some other thing, and the direction will change, right? Okay, so this is tau, right? The time interval. This is the second collision. There is an atom here. So this is a first atom. So the electron from here moves and then hits this atom and will stop, right? So this time interval is the relaxation time tau.
Yes, sir.
Okay, and this distance is the mean free path lambda.
Okay.
Okay, so mean free path metal is this one. The electric field is given as the electric field which can give an average of 2 electron volt energy to an electron is right. See what is the energy of electron here when it starts? Kinetic energy.
Half MV, sir.
And initially it's 0, right? It's starting from rest. And
Yes,
here
sir.
what is the kinetic energy?
M drift velocity square.
So this is the drift velocity. Here it will occur the drift before collision, After collision, the velocity becomes 0. So just before collision is the drift velocity. Okay, so the electric field which can give an average of this much energy to the electron in metal. So this 2 electron volt is this one. The electric field is increasing the energy from 0 to half mvd square. There is no other form of energy. Forget about thermal energy and all. Just leave that one. So the electric field is doing the job of increasing the kinetic energy from 0 to half mvd square. So the electric field which can give an average of 2 electron volt energy to the electron in the metal. So this is half mvd square. So from this we can get Vd. Because mass of the electron is known. Okay, and the mean free path of the electron is this much. So this energy is also equal to it's a force into distance, right? So it's what is the force that's pushing this electron? This force. This is the force on the electron, right? And what is the distance that is traveled?
Lambda.
Okay, and this okay, we have to find this electric field only. So Vd is known, electron charge is known, lambda is given. So from this we can find the electric field. Is this clear?
Vd we don't know, sir. Okay, okay.
Vd is from here.
Okay.
Okay, so you don't have to get exact values of Vd and all. So, so from here we can get Vd as.
So from directly, sir, 2 electron was equal to E lambda. So from there we can directly get the thing.
So Vd is this one. I'm not combining the units at all. 4 electron volt divided by the mass. It is this one.
Sir, 2 equal to E lambda only. Sir. From there we can directly find it. Why should we find the drift velocity?
Drift velocity is what?
You said no, sir, that kinetic energy equal to force into distance.
Yeah.
So we can directly find that electric field, no, from that given lambda value.
Yeah.
Why should we find that the drift velocity?
No, electric field from given lambda value, but you should know the potential difference, no?
They are just ask for the electric field value only, sir.
Yeah.
We can equate no, 2 electron equal to E lambda.
It's energy.
From there, both are energy only.
No.
So the 2 electron was equal to force into distance. You only said no, sir.
Yeah.
From there you can directly find that electric field value. No?
Yeah, you get the answer. So this is equal to what he said is correct. So this is equal to this one. So 2 electron volts means in terms of joules it will be 2 into E joules divided by E into lambda. This is equal to the electric field. So E and E will cancel. So it's 2 by lambda. So it's 0.5 into 10 raised to minus 8. 0.5 into 10 raised to 8. So 5 into 10 raised to 7. Yeah, what you said is correct. So what is the answer?
Third up.
Yeah. You can also write like this: energy gain is a work done that is Q into the potential difference, and the potential difference is E into lambda, right? So 2 electron volts. I'm not changing the units, so Q is E. So from this I can get the electric field as this one. Okay.
Okay.
So this one, the charge particle is having it. So you know the mean free path, right? Whatever is the distance traveled between two successive collisions. Relaxation time tau is time between two successive collisions of electron in an atom or in the inside the conductor. And mean field path is the distance traveled between two collisions.
Yes, sir.
So this one, 2020, it's very recent. The charge particle having a drift velocity this much, the electric field is this much, has mobility. Okay, this is, you have to know the definition of mobility. What is the definition of mobility?
Drift velocity by electric field.
Yes. What is the answer?
2.7
4, right?
Yes, sir.
Done?
Yes, sir.
Okay. This one, 1997. Graph of V versus I. See, you see on the x-axis voltage is there because voltage is independent variable. Okay. Current is dependent variable. Voltage is like more free to vary using a variable voltage source. So voltage is sort of a input to the resistance, and what we are measuring is the current. Okay. So what is the answer here?
CD. But that is 1 by R only. Sir.
Yeah. Sign of R is same as sign as 1 by R. Whenever is R is negative, 1 by R also is also negative.
Okay. CD.
Option?
CD.
Option E.
First option.
Right, because see here also, the slope is not constant, but it is negative throughout. Here the slope is negative, right? Here also it's negative, but it's not constant negative, but it's negative throughout. But here in this second one, here it is positive, here it is negative,
Yes.
middle it is 0.
Yes, sir.
So positive, 0, and negative. But in CD is throughout negative, so there is no confusion. CD should be the correct answer. Here it is positive throughout. Here it is positive throughout. CD negative throughout. BC it's positive, 0, and negative. Is that clear?
Yes, sir.
This one, the electrical resistance of a certain wire of iron is this one. Okay, this is very simple. It's very, very trivial. 2004. You know how resistance is related to length?
R by 2, sir.
You know how the resistance is related to length and area, right?
Yes, sir.
R equal to rho into L by E.
Yes, sir.
Okay, so length is double means if length and radius are both double. So length is double means, okay, length is double. Radius is double means how much is area is increasing?
4 times.
So it's rho L by A. So resistance, so it's decreased by half.
Yes, sir.
Resistance will be half, and the specific resistance will remain. Specific resistance does not depend on the geometry.
Yes, sir.
It's a property. It's like density of a material. Density of the material does not depend on the size of the material, right? 1 kg of steel and 2 kg of steel both will have the same density.
Yes, sir.
Okay, because it's intrinsic property. This one, 10. The masses of wires of copper are in the ratio 1:3:5. Lengths are in the ratio, this one, ratio of electrical resistance. Now to write properly. So electrical resistance, rho R equal to rho L by E. You have to write that one. From that, you have to find how the lengths are related. Sorry, how the lengths are related, how area are related, masses are related. No, masses are related and lengths are related. So from this, you have to find how R are related. Understood the question, no?
Yes, sir. J equal to N E square E tau by M. From there we can find the inverse of M by N square tau. So directly proportional to mass. So inverse of sigma and only rho value, no, sir.
Okay, this thing is fine now. R equal to rho into L by A.
R is equal to rho.
This is the starting. This is the formula, right? Okay, and mass is density into volume.
No, but I took the direct formula, sir. Rho is equal to, sorry, sigma is equal to N E square tau by N. So rho will be M by N E square tau.
No, rho and all is resistivity. You have to find electrical resistance, capital R.
R equal to rho L by A only, no, sir.
Yeah. From there,
So
what?
I'm getting that resistance as M into L into by N E square tau into A.
How will you get tau?
Inverse of conductivity only resistivity, no, sir.
Okay. So,
And conductivity formula is N E square tau by M.
okay.
J is equal to sigma E.
Okay.
And J equal to NDVB.
So, are you getting the answer?
From there, I'm getting M into L, so 5 into 9 into 5. But that is not in the option, so.
Yeah, you don't have to go to the microscopic thing. Okay. So, basically, you have to relate the density of the wire is not going to change because of the length and this thing changing. So, mass equal to density into volume, right?
But after that formula is correct one, you know, sir.
That formula you cannot use here because why do you want to get into the microscope? You don't know tau and all.
Okay, that is one valid only up to that microscopic level only, sir.
No, you should know all those quantities. No, you do not do that. No, see, there's a much simpler way of doing it. Okay, just follow this method. Rho equal R equal to rho L by A, right? Okay, and the mass of this wire of length L and the density D is density into the volume. D is the density, and volume is A into L. So from that we get E as mass divided by D into L. The D is the density. So area I put as M divided by dl, so it will become rho d L square by M. Density is not going to change, and rho is resistive. There's also material power will not change. So in terms of length and the mass, the relation of resistance is L square by M. So resistance is proportional to L square by M. Is that clear? Yes. See here, the given information, the masses ratio and the length ratio. So here you have lengths are there, and rho is the resistivity. That's also not a problem. So only the area I have to get in terms of mass and area. Okay, so area is I'll get from the mass of this wire. Mass is related to density into volume. So from this I get area as mass divided by density into length. So if you put this thing here, I can eliminate area in terms of mass and the length. Density is also constant. So resistance will go as L square by M. Rho the resistivity and D the density of the material. These are material properties, it cannot change from wire to wire. So resistance is going as L square by L. Is that clear?
Okay, sir.
So the length ratios are given. So from that I can get the ratio of R in terms of L is going as 5:3:1, right? So L square will go as 25:9:1, and mass ratio is 1:3:5. So divided by 1:3:5. So the ratio is 25:3:1/5. So this can be rewritten as this one. Okay.
Okay, sir.
This is a simple problem, 2017. Resistance of wire is R. If it is melted into unstretched n times its original length, new resistance will be. We've already done this problem. These are standard questions.
NR,
No, area also will change, no? Length is changing. What about the area?
okay, okay. Okay.
And what will remain constant?
That resistivity.
That is material, that will remain constant, but volume
Constant.
volume of the wire will be constant because mass is constant, density is constant. So volume is mass divided by density. So volume should also be constant. So that will give a relation of how the area is changing. Got the answer?
N square.
B, right? Got it?
Yes, sir.
So volume is A into L is constant. So A1, L1 equal to A2, L2. Okay, so from that we get the area ratio. This one. Okay, this is very similar to the previous one. 2013.
16.
The area is also changing.
That's all from the previous year result we can use here now, sir. N square R.
Yeah. And N is how much?
So
2, right?
2.
Yeah. The wire of 4 ohms is stretched.
4 into 4. 16.
Yeah, correct option B. Yeah, he has made a mistake. Okay, this one. The wire of certain need is stretched slowly by 10%. Same question only, but different way of saying how the length has changed.
Option B by elimination method I can do that.
This one, right?
Yes, sir, but I didn't do that one. By elimination method we can do.
So N is 110 by 100 or 1.1. So 1.1 square is 1.21. Okay, and specific resistance is a material property that will not change, like density will not change. Okay.
Okay.
This one, this is a theoretical question. Which of the following graphs represent the resistivity with temperature for copper? Copper is a metal. It's 2020 question, very recent.
Option 1.
So the resistivity increasing. So this is true for which one? Resistivity decreasing with temperature.
Semiconductor.
And why does that happen?
If temperature increases, then resistance will decrease.
No. Why I'm asking?
Why?
See, the conductivity depends on two things, right? The number of free electrons, the number of free electrons, and also how fast it can move, the velocity, or you can see the drift velocity. In the case of metal, the number of free electrons is fixed because all the atoms, copper atoms, will give 2 electrons, say. And the number of atoms is fixed because the density of the per unit volume is fixed because that is equal to given by the density of the copper. But in case of semiconductor, the number of free electrons will increase as temperature increases. Okay, but the velocity will decrease as the temperature increases because the collisions will be more. Here also Vd will decrease, but the increase of N will dominate. The total combined effect will be the current increasing or the resistance decreasing. Is it clear?
Okay.
Yes.
Yes, sir.
And the thing which is the resistance were increasing linear. Here it is non-linear, right? Increasing it's rapidly. The one which is increasing linearly is which one? With temperature. Like
what, sir?
See here the resistance of copper, it's increasing very fast, no? With temperature.
Yes, sir.
But here it in the case of straight line, it's increasing slowly.
Yes, sir.
So what material is this corresponding to this one? The alloys are designed such that this increase is not that rapid. So it's like a this alloy is designed such that this increase is happening slowly, and the variation is like a straight line. Okay, this alloy is designed so that the variation in the resistance is not much with temperature. Here the variation is very rapid. Here the variation is there, but it is less rapid. But here it is very rapid. With temperature increasing, resistance increases rapidly, much more compared to this straight line. So this alloy is designed such that this variation is not high. Okay.
Sir, what is the difference between second and fourth option? Sir?
Second option, the speed with which it's decreasing. Here it is decreasing rapidly.
Fourth option. Sir.
Yeah. This is decreasing. Yeah. This is decreasing rapidly. Here it is decreasing slowly. Okay. See here the slope is 0.
Yes,
and here it's becoming almost infinity. Here the slope is and as temperature increases, it will become more and more less rapidly changing. Okay. Here it's as if the resistance is decreasing. It's becoming 0 at some temperature, right?
Okay.
Here it is never becoming 0. So this is more realistic. See this thing also, it can increase like this. Okay, but this increase in thing is much more compared to this one. Also it's increasing less rapidly. Here it's increasing more rapidly. So either the increase can be either U or inverted U. So this is more rapid compared to this one, and this is the one that's actually happening. Okay, specific resistance of conductor increases with this theoretical question 2002.
Specific resistance.
Specific resistance is a property of material, but still it will depend on some conditions. Like density will also change, right? Depending on temperature. If temperature increases, density will go down. So similarly, specific resistance also depends on some conditions. So when the temperatures increase, the specific resistance will increase. Okay, it's independent of cross-sectional area because intrinsic property. It does not depend on the area. Increase with it does not depend on the length also. It does not depend on the cross-sectional area. It only depends on the temperature. Okay.
Okay.
As temperature increases, means the number of the frequency with which it collides with the ions is increasing more. So copper and silicon are cooled from 300 Kelvin to 60 Kelvin. Specific resistance. What will happen to the specific resistance?
Decrease in copper. For metal, the resistance will increase. Sorry, increase in copper, but decrease in silicon.
No, it's cooled, no.
Oh, cooled. Okay, then decrease in copper, but increase in silicon.
Yeah, option A. Okay, this is also a simple question. 2018, carbon resistor of value this one. So to find the color code. So how do you remember the color codes? What digit stands for which color, that you have to remember, right? So how will you remember?
BB Roy Great Britain had a very good voice.
Yeah. Okay, fine. So from that you can. So this is clear, right? 4.7 the first digit is 47, and then okay, first you have to write in the proper format. You have to write in this format. 2 digits and then 10 raised to something. Okay, so 47 into 10 cube plus or minus their tolerance. That is 4.7 10 raised to 3. Okay, so 4 is color code, 7 is color code, and then color code for 3. Okay, and then tolerance code, and this tolerance is 10%, right? 4.7 of 47, so it's 10%. So 10% tolerance means silver. Gold is how much percent?
5%.
Yeah, so this is 10%, so it's silver. It's clear now. Okay, this one 2015. This is also a theoretical question.
Electric relation.
Which one?
Electric relation.
No, electric field will, there could be a gradient, no?
Electric field is minus dou V by dou X only. So the potential is
okay, so, okay. What about current?
current is a amount of charges passing through a cross-sectional area per unit time.
Yeah, suppose you take this sort of a thing where the cross section has increased. So the amount of current crossing this area and amount of current crossing this area, will it be same or different?
Different.
Why will it be? Then what? Then there'll be some accumulation, no? It's just steady.
More charge will pass through that broader area, ma'am, sir.
No,
So
no.
more current.
It will pass through more easily. If more charge is flowing through out of this one and less charge is entering this one, so where does the extra charge come from?
Already charge will have passed through that area.
No, if you say the extra charge comes from here, then this region will become charged. No, it should be neutral. So whenever a thing moves out, the another electron should enter. Only this region will be neutral. Otherwise, this will become have some charge.
Okay, then more space is there, more freely it can move, sir.
Oh. Yeah, more freely it can move. So here the velocity of the thing will be more. The drift velocity here will be more. But the current will be same. Whatever charge. See, even if you take a water pipe, hold on. Even if you take a water pipe, whatever amount of water crossing this area is same as the amount of water crossing this area. Otherwise, there will be some accumulation of water here. No, that is not allowed in steady condition. The amount of water in this region is same. So whatever is entering this area should leave this area. But here the velocity of water will be less. Here the velocity of water will be more. So correct option is option B.
But I is V now only, no, sir.
No, don't go to microscopic things.
Okay.
Because you know how the drift velocity is changing. This is almost a theoretical question because there can't be any accumulation of charges here. Whatever is entering here, that thing should leave here. Not just in terms of water flow, no. Water is entering this smaller area should leave this bigger area. Otherwise, there will be a change of mass here. And the volume is fixed. That means the density is changing. That's not allowed.
Sir, I am not electric. Why can't electric will be constantly there? Why should it be varying?
No. First, understand the whatever is entering should leave. Whatever charge is entering or whatever mass is entering, it should leave.
Yes, sir. That I understood, sir.
Electric field is not constant. Electric field is constant if it's of uniform cross section. Okay. So once the cross section is changing, it's as if the resistance is decreasing. No, so it's like a bigger resistance here and a smaller resistance here. Okay, and there's a total voltage. This is a bigger resistance. No, so let me put more. Okay, so if you connect a potential cell here, so will the voltage drop across these two resistances be same? I have two resistances. One is bigger resistance, one is smaller resistance. So voltage drop across here will be more, right?
Sir, but they said they are applying constant potential difference on me, no?
Constant potential is across this one, the entire thing. Constant means not changing with time. Okay, but the amount of drop from here to here is more compared to this one. So here the electric field will be more.
Okay.
E1 will be greater than E2.
Sir, if they said a uniform potential difference, then
where did they say uniform potential difference?
If they said so, then
No.
In that case, what will become?
Then it is not realistic. Uniform potential difference is possible here only, if the cross section is uniform. Okay. Uniform potential difference is not the correct term. They should say constant, or you can say uniform potential gradient. Constant uniform potential gradient is same as uniform electric field. Okay. This is also a simple question. Resistance in each. Okay, end resistances. Each are connected in parallel gives input resistance R, capital R. If these resistances are connected in series, then the combination will have resistance. Okay. N resistances are there. With each resistance values are ohms. Okay. So when they are connected in parallel, the equivalent resistance is capital R. Now these N resistances are connected in series. So what will be the equivalent resistance? This is a simple question. So but you have to do this, write the steps properly.
N square R, sir.
Yeah. So N resistances are in parallel. So the equivalent resistance is R by N, right?
Yes, sir.
And this is capital R, which is given. So when you connect in series, the resistance, equivalent resistance is N into R, and R in terms of capital R is N into R. So it's N square R. Okay.
Yes, sir.
This is also a simple question. Try this one, question number 26. Two 2005.
So I don't know.
See, to draw the figure now, wire is some cross section length and distance is bent in a complete circle. So draw a circle, resistance between any two diameter to opposite points. So across the 2 points, there will be two equal resistance. No. See, this is the wire of length L. So it's been bent and connected as a circle. Now we connect these 2 points. So what is the resistance of this part? With the total resistance is R. Okay.
That part.
It will be R by 2, right? Because length has decreased.
Yes,
Okay. And area is constant. Length has decreased. So the resistance will go down by as R by 2. So the resistance of this part is R by 2. So the resistance of this lower part is R by 2. So these two resistances are in parallel, no?
yes, sir. Yes, sir.
So what is the answer?
R by 4.
Yeah. Yeah, this is also similar question. 27.
Point 3 meter, sir.
This resistance is ohms per meter. It's resistance per unit length. 12. Okay. So what is the total resistance of this circle?
12 into 0.1 meter, so 1.2 ohm.
1.2 ohms. So it's 1.2 divided by, sorry.
Sorry, sir, 2 pi r, no, sir, that length of the full
Yeah.
circle.
Yeah.
So 2 pi into 0.1.
Yeah. Do the calculation.
0.65.
So option B, right?
Yes, sir.
Okay, the important thing that you should not miss is what the resistance is given as per unit. See, in the exam, you have to write in your paper, as soon as you read the question, write 12 ohms per meter. If you put the unit properly, then you will not get confused whether it's resistance or resistance per unit length. So as soon as you read the question, you have to put 12 ohm per meter, and you have to draw the picture of a circle and mark 10 centimeters. See, if I'm giving this test and this question comes in the test, what I do is, as soon as I read the question, I write this thing, 12 ohm per meter. Once I look at the unit, I know what it is. It's resistance per unit length. And then he's saying circle, and then resistance is 10, right? So I'll draw a line like this, and I'll put here 10 centimeters. So and I have to find the resistance between two diametrically opposite points. So I'll draw points like this. So I have to find resistance between these 2 points. So once I draw these things, I don't have to read the question again, and I will not make any mistakes in understanding the question. So this step you should not miss, and you should practice this while being at home itself. Okay, so these are things you have to write, practice while doing at
But
home.
they don't give additional sheet for NEET exam and all, sir.
How
You have
many
to
sheets
write
they
it
give?
on the. Sorry, sir, what?
How many sheets they give?
They just give one that question booklet alone, sir. They won't give an additional paper for doing that.
No, it is not computer based.
No, sir.
Okay, so okay, then that's better. So in the question paper itself, you should underline. Okay, you should underline this one, and if you want, you have to underline this thing twice, so that you don't make mistakes. Okay, okay, because GE, it's all 100% computer. So if they give booklet, it's much easier. So underline whatever is the things which you
Sir,
underline.
but the supervisor will not let us all do any marking in the question paper.
They don't allow you to underline the question paper.
Yes, sir.
And what and what about writing on the side? That's also not allowed. No,
But
you can do some calculation, no?
yes, sir.
So how will you do the calculation?
We just ignore them.
No, no. See, some questions require some calculation. No,
Yes, sir. Sir, but the invigilator says that you should not do right or anything in that question paper, but we ignore the. We
no.
don't listen to them
How do you do numerical calculation?
by mind calculation.
No, no. Are you joking or what? They will be allowed. You will be allowed to do the. If not in the question paper, they have to give separate sheet.
Last one, sir, and then in that question paper itself, last sheet will be plain only, sir.
Okay.
Within that one paper, we have to do everything.
Okay. So in that paper, you have to write this one. First, make sure that you're not a. If first easiest option is to underline the question so that it saves time. If they don't allow that, then in the paper you have to write this, do this step. Otherwise, you make mistakes. This thing you have to do.
In some centers, that invigilator follows, in some centers, they will be too strict.
Okay. I'm actually surprised because in the question paper you will write your roll number, no, and the person who is sitting next to you, their question sequence will be different. Okay.
No,
So,
sir, in that one bench, only one person will be there.
no, one person, even the next bench, the person who is sitting, his question number, your question number is 27, right? For him, this question number will be 7 or something else.
Yes, sir. Yes, sir. Yes, sir.
So there is no difficulty in you marking the question and passing the question to the other one. So the first easiest option is to mark on the question paper, or you have to draw this thing. This thing will take some time, and you have to underline things so that second time when you're reading the question, you just have to read the underlined portion only. You don't have to read the full thing, and also it will be easier to understand if you underline. So this first step you should not skip, otherwise it will be will waste it. Okay, he himself has given the figure, so this figure also you can make use of. So in this figure itself, we can mark here as 10 centimeters. Okay. So how are you revising? So how many problems have you tried from chapter 1, chapter 2?
Chapter 1, that is a kinematic first
No.
7,
Class 12, class 12.
class 12 20.
Okay. And any problem, which one, PYQs or Akash module? Which questions you are trying in the class 12? Huh?
Previous year along with some conceptual questions.
Okay, so if you are not able to solve any question, just send me the snap. You have to solve problems, Iris. It's not a good practice. So chapter 1, electric field and charges, and chapter 2, capacitance. So we are just starting this chapter. So capacitance, last time also I solved some problems. No, so you also have to revise the problems which you already solved. Okay, so your laptop is coming or not?
Yes, by next week.
Next week, why is
My
it?
OS also remains damaged in this section.
OS is damaged.
Yes, sir. That also.
That will not take much time to fix. No, because OS, are you putting the new one or a pirated one? Okay, so that should not take much time. Only the hardware fixing will take time. So
okay, sir.
Because once you have your laptop, because this file is JNT file, you have to use that software in the Windows machine to open this, because one way of revising is to check the notes, because looking at the videos and everything will take more time. Looking at the notes will take shorter
Sir,
time.
my phone is power up, sir.
What? What did he say? What? Okay, shall we close now? So tomorrow 3:30 we'll meet.